Question 7 uses quadratics in a mechanicsy situation. We're going to do a lot of this later in the year. And you're asked to start by sketching this little graph. So if we sketch this graph here, we've got time along the bottom here. And at the top here, we're going for the height. And when t is equal to 0, it starts here at 1, doesn't it? And it's a negative quadratic, so it's going all the way up and all the way down again, something like that. Find the times when the height is 11, so 11 here, so let's write 11 equals 1 plus 15t minus 5t squared. Let's drag everything over to one side. We've got plus 10 there, and look, I could get the calculator out, but let's just divide it all by 5, shall we? Because that's pretty quick to see. We've got to factorize that, and so we've got t equals 1 and t equals 2. So it's crossing at 11 when t is equal to 1 second here and t equals 2 seconds there. When it hits the ground, so for part B, when it hits the ground, that means if that's the height there, the height here is going to be 0, isn't it? So I've just got 0 equals 1 plus 15t minus 5t squared. Well, should we get the calculator for that one? That would be quicker. Let's just grab the calculator. So here's my calculator. Let's put in the x squared value, is of course minus 5 here. We've then got 15 there, and we've got a 1. And it's going to give us one answer there. Let's change that to a decimal. We've got the time equals 3.06 or 3.065. I think I'd write that as 3.1 seconds probably. That sounds about right because we knew 2 seconds up there. And the second answer here at minus, and we're not going to have backwards in time, but look, the minus bit would be at the back there. And so there's our time, 3.1 seconds. It also asks us to find the greatest height, and remember our calculator tells us that the maximum point of this one here is at 3/2 and 49/4, so 12.25. So this point here is 12.25 at 3/2, nicely halfway between those 2 points there. So the highest it will ever get to is 12.25 meters.